Okay, good evening. Last class we discussed about baking soda and its uses. Now we are going to discuss about washing soda. Okay, so you try to understand here. Now, this washing soda. See here they given about washing soda here. See generally by using this baking soda, what they will do is baking soda. You can see here. Baking soda is NaCO3. Okay, so you know NaCO3 is baking soda. On eating this NaCO3, you get Na2CO3. This is called soda ash. This is called soda ash. They will call, okay, along with the carbon dioxide and water is used to produce here. So now this soda ash will be there. This soda ash is going to treating with a water molecules and it forms Na2CO3 10H2. You can say sodium carbonate, sodium carbonate, decahydrate, decahydrate. This is called chemical name of washing soda. We can say now. Second, soda, sodium carbonate decahydrate is a chemical name of this washing soda. Now see, this process is called a recrystallization. See, the sodium carbonate is treating with an water molecules and this process is called recrystallization. Just remember here. Again, you have seen above the sodium carbonate can be obtained by heating the baking soda. The recrystallization of sodium carbonate gives washing soda. It is also used also an basic salt. Remember, baking soda gives washing soda, which is a basic salt. This you should remember. Here they given the reaction here. Na2CO3 sodium carbonate, or we can say is called soda ash. They will call soda ash is treating with the water molecules. It is forming Na2CO3. 10H2O. It is called decahydrate. Okay. So now we can come to the next get into the next one, see what does this 10H2O signifies. This is here is a important thing here. This 10H2O signifies does it makes Na2CO3 wet and will we will address these questions in the next section. Sodium carbonate and sodium hydrogen carbonate are useful chemicals for the many industrial process as well. So now they are given here uses of washing soda. Sodium carbonate washing soda used in the preparation and manufacturing of glass industry, soap industry, and paper industries also they will use. It is used as a manufacturing of sodium compound like a borax. Okay, so I think you know about borax. It is used in the powder, right? Which is used to cure the wounds and things. So sodium carbonate can be used as a cleaning agent for the domestic purpose. Means in the cleaning of what we can say soap industry they will use. That's why they use this one soap. Okay, now it is used to remove the permanent hardness of water. So you know very well this calcium plus 2 ions and magnesium plus 2 ions are there, which are going to causes the permanent hardness. Not only this one, permanent hardness and not only we can say chlorides will be there, chlorides, and after we can say sulfates. These are the chlorides and sulfates of calcium and magnesium salts are for making the water into hard water, permanent hard water, permanent hardness it is going to create, and this can be removed by the adding of sodium carbonate. You try to understand here. So when we are suppose you think like we have a magnesium into hard water, we have a magnesium salt. That is, if we are adding the sodium carbonate, baking washing soda, these ions are going to replace this magnesium ions. Okay, magnesium ion, which gives the soluble substance, which is makes that water into soft water. Okay. Now one more concept, very important concept. It is also given something called about water of crystallization. Are the crystals of salts are really dry? They given the I eat a few crystals of copper sulfate in a dry boiling tube. Just to see here, yes, I want to explain here. So try to understand here. Now, this experiment is important actually. Now see here. Now we should understand the activity. Let me read out this activity first. Right? Now see they are taking eat the few crystals of copper sulfate. So you know very well what is the copper sulfate color, sir? It is an blue color. This to remember, please. Okay. Now what is the color of copper sulfate? Answer is blue color. Do you notice water droplets in the boiling tube? Where have these come from? Okay. Now see when you are eating this copper sulfate, which is a blue in color, on eating slowly, water droplets are going to settle at the wall of the boiling tube. Boiling tube means nothing but what, sir? It is a test tube. Okay, test tube is also called a boiling tube. Remember. Now, what they are saying, when you are going to heat the copper sulfate crystals in the test tubes, slowly water droplets are going to deposit upon the wall of the test tube. From where these water molecules came actually, you try to understand. Okay, 2 to 3 drops of water on the sample of copper sulfate obtained after heating. Add 2 to 3 drops of water on the sample of copper sulfate obtained after the heating. What do you observe? Is the blue color copper sulfate restored or not? Absolutely, it will restore. Okay. So what is the reason here? See, try to understand here. This concept is nothing but water of water of crystallization. Water of crystallization. You try to understand generally. So here there is an copper sulfate. This copper sulfate is usually it is a blue color sulfate. Blue color copper sulfate will be there. Okay, if we are eating this, blue color copper sulfate, okay, it is going to become a colorless. Suppose if you are going to heat, it is on eating, this copper sulfate is going to become a white color. It will become white color. Okay, white color copper sulfate molecules will be there. Okay, and details try to understand. On eating, this color white color will be there. Just let me write here better. So color of crystals will be blue color, and this will be what color, sir? This will be an white color. Okay. And one more thing in the test tube they given when we are supplying the heat energy. Okay, you try to understand here. Here they are they are when they are going to heat, you can see there is an deposition of water droplets upon the wall of the when they are supplying the heat energy. Okay, you can see there is an water droplets are going to deposit upon. These are the nothing but H2O molecules. H2O molecules. So actually, from where these water molecules are created, actually, from where they came actually. See, answer is here. This is CSO4. Now, what is the color set? It is CSO4. Color is what, sir? It is white now. It becomes colorless, we can say. Now, what is the color here? It is an blue color. Actually, you see that understand. Let me write the formula so you will come to know that. Okay. Now, see here. Now, actually, this copper sulfate have a formula copper sulfate pentahydrate. So there is a 5 water molecules along with one CuSO4. Okay. When you are supplying the heat energy, you try to understand. Again, I am saying color of copper sulfate will be blue color. It is also called blue vitriol. It is also called blue vitriol. They will call. Okay. So now on eating this copper sulfate is going to lose its 5 number of water molecules. Okay, so due to this one, it is going to become white color, or we can say colorless. Now see this dot represent what, sir? It is nothing but Van der Waal force of attraction. Remember, Van der Waal force of attraction. You know very well. This is maximum arises between the molecules. Here, anyway, as copper sulfate is ionic compound, we are not supposed to call as a molecule. It's supposed to call formula. Okay, one copper sulfate formula have a 5 number of water molecules. Anyway, between that 5 number of water molecules and copper sulfate, there is force of attraction, which we are calling as a Van der Waal force of attraction. Just remember. Now see here the point is that is not a point actually. Here 5 number of water molecules was there, and those are water molecules are get separated from the copper sulfate on eating. Okay, so up to until this 5 number of water molecules was there with the copper sulfate, color was blue color and it have a particular shape. Okay, so once if it is going to lose, when it is lost the water molecules, it lost its color also, shape also. Okay, so that is called water of crystallization. So what I am saying here, every salt have a definite, every salt have a definite shape and as well as even color also. Okay, this shape and color is depending upon the water molecules. Okay, number of water molecules will be there, no? So these water molecules actually gives the color and shape for the salt, that is called water of crystallization. Now when come to the copper sulfate have a 5 number of water molecules. So on heating it is going to lose that 5 number of water molecules. So in that time it is going to lose its color also, even its shape also. You see, they given the activity, they are saying that, they are saying add 2 to 3 drops of water molecules on the sample. After doing the activity we are going to get white color copper sulfate, right? White color copper sulfate. Now what happens if you are going to add for the, now see, right side we have copper sulfate. For this one, if you are going to add the water, what happens? Definitely it is going to become again a copper sulfate dot pentahydrate. So now again what happens are again blue color is going to reappear. It is going to restore its color. So once if it is going to lose a color, it means it lost its water molecules. Okay, so salt have a definite number of water molecules associated with them, which are the cause for their colors as well as shape, that you remember. And that number of water molecules are called water of crystallization of that particular salt. Now what is the water of crystallization of copper sulfate? Sir, answer is 5. This number represents 5 number of water molecules. Okay, similarly we have different what we can salt. We have, like, we have example, like we have a FeSO4, right? FeSO4 have a 7 water molecules. So what is the color, sir? It is a pale green color, pale green. What about NaCO3, sir? NaCO3, what we can say, no water of crystallization, but you write water of crystallization, WC. Okay, what about the washing soda, Na2CO3? How many Na2CO3 have a formula of, there are 10 H2O molecules are there. This 10 is called water of crystallization of washing soda. Similarly, what about CaOCl2, sir? So bleaching powder doesn't have any water of crystallization, no. What we can say, no water of crystallization. Similarly, we have one more salt, CaSO4 dot 2H2O. This is called what? This is called something else. What it is called? It is called gypsum. Gypsum does, this gypsum have a 2 water molecules. So we can say 2 is the nothing but water of crystallization of gypsum. Suppose we have something called CaSO4 dot of H2O. This is nothing but POP, plaster of Paris. So plaster of Paris water of crystallization, sir, it is a half, remember. So these number are important. Okay, similarly we have different salts have a definite shape also, color also, because of they have a particular number of water as water molecules associated with them. That what number of water molecules are called water of crystallization. Please remember. Okay, so again I am saying here, again I am saying what I'm saying here, try to understand. So we have a different types of salts are there, and they have a particular color, as we discussed in case of copper sulfate. See, copper sulfate have a blue color. Blue color is because of it have a 5 number of water molecules associated with the copper sulfate. Those 5 number of water molecules are responsible for its color also, as well as its shape also. Okay. Similarly, we have a FeSO4. FeSO4 have a 7H2O. It is called ferrous sulfate septahydrate or heptahydrate. That 7 molecules are responsible for the color of the iron sulfate. Similarly, we have zinc sulfate. We have a magnesium sulfate. Different salts are there, and you have even just now we discussed about which is called plaster of Paris. Formula is CaSO4 half H2O. That half is called water crystallization of plaster of Paris. Similarly, we have gypsum CaSO4 2H2O. What is the water crystallization of gypsum means? They should say 2. What about baking soda? Baking soda doesn't have any water molecule. That's why water crystallization of baking soda would be 0. Similarly, washing soda have a 10 number of water molecules. Similarly, calcium oxychloride, bleaching powder doesn't have any water crystallization. Try to understand. Okay, now come to the next concept. Okay, so now see, they given about next concept here. They given about preparation of this is see one more thing. Let me read out here. Copper sulfate crystals, which seems to be dry, contain water molecules. So they are asking the question that whether these molecules, now just now we come to know that this copper sulfate associated with the 5 number of H2 because of this water molecules, whether this copper sulfate is wet or dry. That is the question. Answer is it is not wet. It will be dry. Okay. Now water crystallization, heat crystallization, blah blah blah. Again remove and if moisten the crystal again water, you will find the blue color crystals appears. Okay, so water crystallization is a fixed number of water molecules present in one formula unit of salt. They given one formula unit. They are not saying molecule, they are saying formula unit. Now see what they given, sir. They given here CaSO4. CaSO4 dot of H2O. It means what, sir? It means one formula of copper sulfate is going to share the of H2O. Okay, now see, 5 water molecules are present in the one formula mass of copper sulfate. Chemical formula of hydrated copper sulfate is CuSO4 5H2O. Now you would be able to answer the question: water, whether the molecules of Na2CO3 10H2O is a wet or dry. It is a dry. One other salt which is possess water crystallization is gypsum. So has a 2 water molecules of crystallizations. It has a chemical formula CaSO4.2H2O. Let us look into the uses of this salt. What are the uses of this salt? Plaster of Paris. So this gypsum is there. No? Gypsum is used to, by using this gypsum CaSO4 have a 2 number of water molecules. They are going to heat at 373 Kelvin. Okay, it gives rise to CaSO4 dot of H2O plus 1 and of H2O, 1 end of H2O, and this is called POP, plaster of Paris. You remember, okay? So heating of gypsum at 373 Kelvin, it loses its water molecules and becomes calcium sulfate hemihydrate, means of H2O. This is called plaster of Paris. Okay. Now plaster of the substance which doctors use. See what where this POP is used actually. POP is used by the doctors, used as a plaster for supporting the fractured bones. So this word can be asked as a int. If they are saying int like fractured. Okay, they given word fractured. Fractured bone means the question is asking about what's that? POP. Just remember, many questions ask this question. Many question paper contain these questions with this word. Fractured bones in the right position. Plaster of Paris white powder. They given very important. This sentence is very important actually. They given here. Especially, just let me underline this important hints during where they ask the question about by giving these kind of hints. Okay. Now see here. So these words are important actually. One is fractured bone. One is fractured bone. Second one is given white powder. White powder on mixing with water. These words you can able to see in the question paper. It changes into gypsum again by giving the hard solid. So CaSO4 of H2O plaster of Paris, adding unit of H2O gives rise to CaSO4 2H2O. Not only the half molecules here. One more thing. Note that only half of the molecules is shown by attached water of crystallization. How can you get half molecules? It means that you try to understand. They are saying about plaster of Paris. Plaster of Paris has how many number of water molecules are half H2O? Is it half H2O exist? Actually, answer is no. It means that there is one H2O molecule. Okay. So this side also there will be an what's a CaSO4. Okay. Even this side also there will be what's a, it will be an CaSO4. It means that these two CaSO4 units are going to share this one molecule of water. This means that CaSO4 of H2O. Okay. So plaster of Paris used for making toys and material for the decoration and for making surface, smooth surface, gives to try to find out why this calcium sulfate hemihydrate called plaster of Paris. So that is question for you people. You can go to this one. Now come to the blue question here. They given the blue question. Blue question. What is the common name of the common name for the compound? What is the common name? Sir? It is bleaching powder. Common name is called bleaching powder. Is a common name for CaOCl2, calcium oxychloride. So now name the substance which treatment with the chlorine yields a bleaching powder. Which ones are? This is CaOH taken twice. Calcium hydroxide, or we can say slaked lime. They given name the substance, so we should write as slaked lime, or we can say calcium calcium hydroxide. This is should write. Why? Because they asked name. Okay. Name the sodium compound which is used for softening hard water. Name they given. Again, name means what, sir? It is washing soda. Washing soda. Or we can say what, sir? It is called sodium carbonate. Is it correct? Sodium carbonate. What it is, sir? It is decahydrate. Decahydrate. What will be happens if the solution of sodium hydrogen carbonate is heated? Give the equation for the reaction. So we discussed already. NaCO3 on heating gives rise to Na2CO3 plus H2O plus carbon dioxide gas is going to produce. Next, give the equation for the reaction involved here. Write the equation to show the relation between the reaction between the plaster of Paris and water. Reaction between the plaster of Paris and water. Let me write here. So we have equation CaSO4 dot of H2O plus 1 by 3 by 2 H2, 1 and half H2O gives rise to CaSO4 dot 2 H2O. This is gypsum. So plaster of Paris is going to react with the water molecules. It is gives rise to gypsum. It is nothing but a very hard substance. That's why they will ask the question, why this calcium sulfate hemihydrate POP should be stored under the waterproof container, waterproof bag, because if it is once come in the contact with water, it gives rise to gypsum, which is an hard substance. That is the reason why we should not store the plaster of Paris in the moistured area. Okay. Now they come to the question here. So solution turns red litmus to blue. What is the pH like? Solution is there. It is turning into red into blue means what it is, sir? Blue means basic, which is greater than 7. Greater than 7 means it is less than 7, not less than 7, not correct. Next answer, not correct answer is option D. Solution react with the crushed eggshell. What is the formula of crushed eggshell, sir? CaCO3, metal carbonate gives rise to metal carbonate plus what, sir? Acid gives what, sir? It gives a CO2 gas. They are saying that gas that turns lime water milky means CO2 gas. So our option should be acid. NaCl is a salt, not acid. HCl is an acid, correct? Okay. Lithium chloride is a salt, not correct. Calcium is salt, not correct. Answer is option B. Now 10 ml of this NaOH found to be completely neutralized. 8 ml of given solution HCl. If we took 20 ml of same solution of NaOH, how much is required? See, 10 ml can neutralize 8 ml, then 20 ml can record how much? 16 ml is the answer. Okay. Now, which are the following types of medicines used for treating indigestion? We discussed something called antacids. Antacids can neutralize this one. What's the problem which is caused by the food? Okay, write the word equation. Word equation. As in question, that write the word equation. Then balance the equation for the reaction taking place. Dilute sulfuric acid react with an zinc granulase. So let me write about here. Dilute dilute H2SO4. They are asking to write word equation. Let me write here. Dilute sulfuric acid. Okay. So dilute sulfuric acid. Sulfuric acid plus they given zinc gives rise to what? Gives rise to it gives rise to zinc sulfate plus hydrogen gas. Now we can write here dilute dot H2SO4 plus they given here Zn gives rise to ZnSO4 plus H2 gas. Okay, this is gas and this is an aqueous solution. This is solid. This will be the again aqueous as it is diluted. Okay. Now fifth one, this is A, right? Now come to the next question. Next question is dilute hydrochloric acid react with a magnesium ribbon. So they given here again. Next, let me discuss about next one more thing is dilute hydrochloric acid. So we can write here dilute hydrochloric dilute hydrochloric acid plus magnesium ribbon. Magnesium we can write gives rise to. So what we can say? We can say it is nothing but magnesium. We get magnesium chloride. Okay, magnesium chloride plus hydrogen gas. Okay, so how we can write here? Hydrochloric acid dilute HCl plus magnesium symbol is Mg gives rise to MgCl2. MgCl2 plus hydrogen gas. Liberation of hydrogen gas, upward arrow mark. Now see here how many chlorines are, let me write here 2 HCl, then it is balanced one. Next come to the next question. What is the next questions are they given about dilute sulfuric acid with aluminum powder. Dilute sulfuric acid and aluminum powder. Okay, so you can see here, right? Dilute sulfuric acid. Okay, sulfuric acid plus aluminum. Okay, aluminum gives rise to what happens are aluminum sulfate will form aluminum sulfate plus hydrogen gas. Okay, these are you try to understand. They are making the acid plus what's that metal. So now see sulfuric acid diluted H2SO4 plus Al gives rise to Al2SO4 taken thrice.